Okay, so in this demonstration what we're going to do is solve two equations simultaneously using a graphing method. As you can see on the screen, I've got the TI-84 next to me, and so we'll be able to do it step by step. Clearly what we can see to start with is that the calculator only inputs y equals, so I can do y equals anything I want. But the equations that have been given, there is no such thing as a y equals just on its own. So the first thing we need to do then is to rearrange each formula. I'll call it a formula, I should be saying each equation. So 3x plus 2y equals 7. I'm trying to get y on its own, so I will subtract 3x from this side and subtract 3x from that side. This will leave me with 2y here is 7, take away 3x. Okay. Now here then, if I divide this by 2, I will get y, which is what we want, so I will have to divide the other side by 2 as well. So in other words, y equals 7 minus 3x all over 2. That's the same equation, just rearranged. Similarly, let's do the second one. Okay, a slightly different way. I'll subtract x from this side, therefore I have to subtract x from the other side. X take away x disappears. We're still left with negative 3y now. Now in order to get negative 3y into 1y, I need to divide by negative 3, because negative 3 divided by negative 3 is 1. So this will give me y equals 6 minus x over negative 3. Bit messy, but I mean, it's okay. The other alternative, which is what I've been telling you before, is I think it's a little bit nicer. If I start with x minus 3y equals 6, the first thing I said to do is, if the thing you're trying to find, i.e. y, is negative, then take it to the other side. I can do that by eliminating it on the left and adding it to the right. Okay. From here, I need to get rid of the 6, so I'd have to subtract 6 both sides, which gives me x take away 6 equals 3y. And then in order to get 3y to become 1y, divide by 3, divide by 3, and you end up with x minus 6 over 3 equals y. These two equations are the same. 6 minus x over minus 3 and x minus 6 over 3 are identical. Won't go into it at this point because what we're doing is graphing. So now we need to graph the two ends, so we'd graph 7 minus 3x over 2. Note the brackets. 7 minus 3x brackets divide 2. Scroll down. Next one. I'm going to use the second equation down there. Brackets. X minus 6 bracket divide 3. And we're at that point there. Now we've entered the equations. It's a matter of now graphing them. And remember, whatever window you had before is the window that will be there now. So let me have a look. I have no idea what I'm going to see. There you go. Oh dear. It doesn't look very good at all. Okay. It doesn't look very good at all. But I don't panic. I simply do zoom 6 is usually a good start point. There's one equation. And there's the other equation. Now that looks okay. I don't need to do any adjusting. And what we're now going to do is going to try and find the point of intersection. We do this by choosing second trace, which is the calculate section. And then we need to do the obvious one, which will be intersect. So which is 5. It says first curve. It doesn't know it's a straight line. All right. The calculator will always say curve even though it's a straight line. Please don't worry about that. What we're saying is it's on the first graph, enter. It jumps onto the second graph, enter. It asks you yes, you press enter. There's your point of intersection. x equals 3, y equals -1. So that's it. We have x equals 3, y equals -1. Done.